Session we are going to derive expression for a capacitance of a metallic sphere which is kept under the dielectric constant K, uniform dielectric constant, and here you have a sphere and this sphere have a total charge Q on its surface. Our regular method to find out the capacitance is a very first step is like find out the electric field at any point X from the center of this sphere or from the center of the system. Then you integrate it and find out the potential at this point. Once you get the potential, you will get the relation between Q and V. Then using Q is equal to CV, you find out the constant C. That will give you the capacitance of the system. So first I will find out the electric field at a point P. The electric field at a point P will be 1 by 4 pi epsilon naught K into Q by X square. Okay, now find out the potential from point R, which is radius of a sphere, to infinite E dx. This is nothing. Then you find out the constant, you take constant out, 1 by 4 pi epsilon naught K and Q, and integrate it from R to infinite dx by x square. After integration you will get 1 by R. This whole bunch of thing will give you 1 by R. This one will give you 1 by R. Okay, now you will get it V is equal to, you will get like nothing. There's some issue here, but anyway it's fine. V is equal to Q by 4 pi epsilon naught K into R. Okay, now C, value of C. Q is equal to CV. Compare with Q is equal to CV. You will get C here. You will get C over here. C will be, oh sorry, C will be equal to 4 pi. There's something wrong here. Okay, let me write it cleanly. So your C will be equal to 4 pi epsilon naught K to R. This is the capacitance of a spherical capacitor. In the next session we will talk about the capacitance of a capacitor which is kept in the dielectric constant, in different kind of dielectric constant, means up to radius R2 Up to radius r1 means sphere will be there, and after the distance means after the surface, you will have a dielectric constant k up to radius r2, and then you will have dielectric constant 1. So it will be something like you have a sphere here, this sphere is having a radius r1, and then you have a dielectric constant, here, and this is dielectric constant, up to radius r2, and then you have, this is k dielectric constant, here k will be equal to 1, right, in this direction. The same thing now, what you need to do is like integrate your electric field from r1 to r2 and then r2 to r1. Means what you will do, v will be equal to integration from r1 to r2, it will be e1 dx plus integration r2 to infinite e1 dx. e2 dx. Okay, integrate it and find out the relation between q and v. With q and v you will get c. Okay, this e1, what about this e1? Let me write expression for e1. This is nothing, this e1 will be equal to 1 by 4 pi epsilon naught k into 1 q by x square. This one is x square. Let me write it with other pen. This one is nothing but x square. Okay, now here this one 1 by 4 pi epsilon naught k is 1 here q by x square. Okay, only difference is that here you will have k, here you don't have k because k will be 1 in this reason. You integrate it, find out relation between q and c. Or I will tell you the relation, means I will write down the value of c. That value will be 4 pi epsilon naught k, 4 pi epsilon naught k r1 r2 divided by r2 minus r1 plus r2 minus r1 plus kr1. Okay, in the next session we will derive a capacitance of concentric metallic sphere. We will have a two sphere, inner sphere and outer sphere, and these two sphere will form a capacitance, will form a capacitor, and we'll find out the capacitance of the system of the capacitor in the next sessions. Till then, bye bye.